Davis, and I'd like to present my senior project, Sheila, the RC Baja. Me and my partner worked on this throughout the entire senior year. I was in charge of the steering and suspension system of this vehicle. I would like to go through some of the analyses that I conducted to give me the dimensions that were required to meet my requirements, as well as the manufacturing phase of this project, and some of the tests conducted to ensure that this project met or did not meet some of the requirements that I had set in the bulk order. To begin, I'd like to talk about the analyses. Some of the requirements that I had set for this vehicle is that it would not weigh more than 10 pounds, that it had 2-inch clearance between the chassis and the ground, that it would not deflect more than 0.01 inches in the suspension system after a 50-pound load, a turning radius of 3.5 feet for a 180-degree turn. Here we can see the analysis for the control arm, which was to give me the dimensions based on this 50-pound load. The dimensions came out to be about 0.3 by 0.3 area for the component. The steering angle was done using simple trigonometry, given the tire center length, which was conducted here using 14 inches. However, this is a much longer car than we had originally anticipated. It is at a total of 19 inches from front to back, excluding the bumper. Backtracking a little bit, the control arm analysis was done using the deflection equation found in MOT to determine how much it would deflect given that requirement of 0.01. Analysis of the spring constant for the shocks used was done using conservation of energy between the potential energy of a drop of 4 feet and the kinetic energy of a spring, setting those things equal. And a couple of other analyses were done to determine other dimensions of the vehicle. Moving on to construction. Construction was mostly done in 3D printing to accommodate for ease of manufacturing, given that we have a lot of complex geometry, especially for the front end components. This was very beneficial to the group, as neither my partner or I were super confident in our machining, but we were very confident in our SolidWorks. We found a lot of problems, however. Neither of us owned a 3D printer, so we relied heavily on Central Washington's 3D printing room, as well as some classmates offered up their own printers for us to allow manufacturing to happen without our presence. This was very, very beneficial, and I cannot express our gratitude enough to Central Washington University and our peers in the senior class of 2024. Furthermore, we encountered issues with the printing itself, as some of these prints are long and tedious and had multiple failures. A lot of them found adhesion issues with the bed, just random problems while printing where maybe the printer got clogged overnight and the print had to be restarted. Furthermore, this project has been in a phase of constant improvement. That means that we have made a part, something happened, or we didn't like it, and we redesigned it, reprinted it over and over until we finally have a design that we like. This being said, the design phase has bled all the way through into the testing quarter, which is not necessarily a good thing, but it is beneficial for the car, as it is performing a lot better than it originally did. Here you can see a lot of the prints getting put together. As you can see, they are changed from the picture to what is actually on the vehicle. This is that state of continuous improvement. And there's a little video of some of the components being printed. This was also difficult because we had to hand thread all of the components so they would actually fit together strongly while still having that ease of manufacturing. Moving forward into testing. 3 main tests were done for this vehicle. There was a drop test where the vehicle was supposed to be dropped up to a height of 4 feet. However, we found that the vehicle would bottom out after anything over 1 foot. This test was then revamped to accommodate for that 1 foot drop. So we had 4 instances, 3 inches, 6 inches, 9 inches, and 12 inches for the drop. As seen here is measured with each drop with a measuring tape in front of the vehicles. and it's paused to accommodate to determine the actual displacement of the vehicle. Screenshots here are shown to see where and how far the front end displaced. This is then used into a spring equation to determine the average shock or shock constant value. Since this vehicle does use two different shock components, we want to go with an average rather than trying to evaluate each of them specifically. The next test was done as a deflection test on the weakest component. We had found throughout the year that these upper control arms were the ones to break the most. So I wanted to make sure that they were strong enough to withstand the forces that would be acting on them. So placed in the Instrom here in Hogue 127, first off, the first trial was a 34-pound load to see if it would withstand that, which it did to meet the requirements. Following that was a 50-pound plus load. Calculated value for this was almost 0.1 inches based on that 57-pound load. However, the realistic value was only 0.41 or 0.0412 inches, which is far beyond our expectations. This was a very good sign to say that these parts are structurally sound to meet these requirements and withstand the forces that we intend to be acting on. Turning test is the final test conducted to try to meet that 3.5 foot radius for the 180-degree turn. However, the vehicle failed in this with its minimum turn angle of the left tire being 4 degrees, which is substantially lower than the required 19 degrees. This leads the engineers, my partner and I, to want to redesign the steering system to meet this requirement and look at new components that might be able to help us get there easier. However, this late in the school year, we do not have the time as of right now. Another problem is during the Baja competition. We placed dead last, unfortunately, because we had suffered a catastrophic failure in the steering system where a tie rod became undone, causing us to collide. After this collision happened, our team said no more, never again. So we actually went back and redesigned the front end to add a buffer to protect these components from breaking again on a collision, as well as added a cover to keep the internal electronic components safe from any environmental wear and tear, as well as to give it some aesthetic, because who doesn't like something to look good when you actually are trying to sell a product? It is very important. We added some LEDs as well, so it'll look extra cool. Style points are important in any market. Lastly, I'd like to talk about the schedule and budget of this product. The vehicle became behind schedule as we pushed into winter and spring quarter because of all the redesigning we had to do. This fall quarter we were on schedule throughout the analysis and design phase. However, as I said earlier, this project is in a state of continuous improvement, so it is in a redesign phase almost entirely throughout the school year. The winter quarter, as I said, was dedicated to manufacturing, which was done primarily through 3D printing. And the spring quarter was focused on the testing. Again, during testing we had parts break, so we had to go back into manufacturing multiple times, as well as redesign. But ultimately those were all better choices because of the fact that we were able to reevaluate the components so they would better fit together, be stronger, more structurally sound, as well as just look better aesthetic-wise. Lastly, I'd like to talk about the budget of this project. It was originally estimated at $400, which was met in our initial manufacturing phase. However, between our winter and spring quarter, we did some design changes and decided to go with some new components, as well as had some components fail. So the new components are the shocks in the front, as well as these new tires, and the motor and ESC needed to be replaced, which put the project over budget by over $200. This is unfortunate, but necessary to make sure it was a successful project. Thank you, and I'd like to open the floor to any questions.